Okay, so we need to start off by reviewing what it means to be an inequality. Okay, we solved inequalities before, right? When we solved for x, what made it an inequality? Our symbol. What did our symbol become? Instead of equals, it became less than or greater than, right? Or it was less than or equal to or greater than or equal to. Okay, so instead of the equal sign, we got one of those things instead. Okay, so this time when I graph a line, that's going to change my line. So before I had open and closed circles, what did the closed circle represent? Equal to or not equal to? Equal to. Equal to. And my open circle was not equal to. So something's going to happen when I actually draw the line also. So the dashes, yeah, is the dashes, you're right. Is that going to be when you're equal to or not equal to? Not equal to. So if you're missing that solid line in your symbol, you're going to be missing pieces of your line, right? So it's going to look something like this when we graph it. Okay. What is it going to look like if it's equal to, though? Then it'll be solid. Okay. So I'm going to keep my solid line. So after we graph the line, though, we also have to remember how to shade. So if we are greater than the line, where are we going to shade? We're going to shade above. Yes. Forgive my shading. So over here, above is on top. Okay. Where would below be? So, sorry, where would less than be? That's my question. Less than is going to be under the line down here. Under the line down here. Okay. So to be greater than our line is above. To be less than our line is below. Because we're saying y is greater than. So I need all the y's to be bigger. That's why it goes up. Y is less than something. My y's are getting smaller. That's why we shade down. Okay, so we understand how the graphs are going to look. Okay, beautiful. So now, yes, yellow is greater than and the blue is the less than. Yes, sir. Okay. So now let's look at talking about what is going to be a solution or not. Okay. So a solution means it's going to fit into my graph. There we go. So I want to check if the ordered pair is going to be a solution or not. So how can I check to see if negative 5, 0 is going to work in this equation? Plug it in, absolutely. So let's plug it in. So it's going to become 5 times negative 5 minus 0. And I want to know, is this going to be greater than 2? Is this going to happen? Well, let's see. What is 5 times negative 5? Negative 25. And what is negative 25 minus 0? Negative 25 minus 0 is negative 25. And is this value bigger than 2? No, it is not. No. So is negative 5, 0 going to be a solution? No, it is not. Negative 5, 0 is not a solution. Okay. Can you test if 523 is going to be a solution? All right, I want you to try that. So you're going to test 523 using the same equation. All right, so are we saying yes, it's a solution, or no, it is not? Yes. Ooh, I hear a little bit of both. Okay, let's work it out. What is 5 times 5? 25. 25. What is 25 minus 23? 2. Is 2 greater than 2? No, it is not. Okay, so because it did not say it could also be equal to, it only said greater than. So 2 is not greater than 2. Therefore, this point is not a solution.
So keep one side on one side?
Yes, if it said greater than or equal to, then we could have said yes. But in this case, it is not going to work. All right, I want you to try number 2.
I know I tried number 2.
I want you to try number 2. Don't be scared about the fraction. The fraction is 1/2. You know what 1/2 of 20 is. You know what 1/2 of 4 is. You'll be okay. So I want you to test the point 21 and the point 4, -2, into the inequality 1/2 x minus 7y less than or equal to 5. So remember, greater than means it's going to eat the bigger number. So this is saying this whole function needs to be less than or equal to 5. Check with your neighbor. See if we're getting the same thing. See if they said yes, if they said no. Do you agree? Check. Maddox, I want you to check with Kyle. See if we're getting the same thing.
How about the other one? Did you do 16? Not you got it. 16 is not working. So you got Richard got 9.
All right, Micah.
No,
The point 21, is it a solution? It is. All right. So what happened when you did 1/2 of 20? What is that? That is 10. And what is -7 times 1? And what is 10 minus 7? It is 3. And is 3 less than or equal to 5? Yes, it is. I'm going to do a smiley face. Yes. Okay. So the point 21 is a solution.
Yes.
So we like that one. That one is yes. Good. All right, Micah, popcorn off to someone else for me. Who? Tyler. Okay, Tyler. The point 4, -2. Did you say it was or was not? It was not. Okay, let's see if he's right. What is 1/2 of 4? It is 2. What is -7 times -2? Positive 14. What is 2 plus 14? Is 16 less than or equal to 5? No, it is not. Wah, wah. It is not. So, is the point 4, -2 a solution? It is not. It is not a solution. What would that look like on a graph with the shading and the lines? To be a solution, do you think it would be in the shade or out of the shade?
In the shade.
In the shade, yes. If it is not a solution, where is it going to be?
Out of the shade.
Out of the shade. Very good. Being on the line depends on if we can be equal to the line or not. Okay, so if we're on the line but the line is dotted, it is not a solution. If we're on the line but the line is solid, then it is a solution. So you gotta be careful with when it's on your line. Pay attention to what kind of line we're drawing. All right, you ready to draw some lines and shade? Yes. Yes. That's gonna get me. No, it's not. Okay, here we go. Number 3. Do I have to change the way number 3 is written before I graph it? No. How come? It's y is by itself, which means we're in the y equals mx plus b, the slope-intercept format. So how am I going to start drawing my line? Where are we going to go? We are going to start at a y-intercept of 2. And how am I going to move to my next point? Down 3. It's because it's negative 3, right? So 1, 2, 3. To the right 1. There we go. 1, 2, 3. Right 1. Good. Okay, now before I draw my line, I need to know what kind of line I'm going to draw. So is this going to be a dotted or solid line?
It's going to be a dot.
How do you know it's going to be a dotted line? Because it is not equal to. Good. It is a dotted line because our symbol is just less than. So there's not equal to, not solid. Okay? So we will have a dotted line. All right, now when it comes to shading on this dotted line, where are we going to go with my shade? Are we going to go above or below? How do you know we're going to go below? Because it is less than. Because all of my y's have to be less than. So we're going to go all down here. Notice my y values are getting smaller when I am below my dotted line. Okay, we good? Okay, now I'm going to ask you a question. Is the point 5, 2 going to be a solution to this set, to this inequality? 5, 2, that is what? That is about right here. Is that a solution? It is not a solution. Why is it not a solution? It is not in the shaded area. Good. How about negative 5, positive 2? Yes, this one is, because where is it? It's in the shade. So we like this one. We do not like this one. Hate is a strong word. Okay, how about our y-intercept right here of 0, 2? Is that going to be a solution?
No, because it's not.
There we go. No, it is not. Okay, because my line is dotted. Wah, wah. Because our line is dotted, that is not going to be a solution. All right, good. Yes, sir. Because it said less than, so I had to go below. Less than means shade under. All right, I want you to try number 4. You try number 4. You are trying number 4. Did you have to change the way it was written? First off, no, you don't have to change the equation. When you're done, check with your neighbor.
Oh, isn't it going to be above?
I don't know, is it?
Yes.
What kind of line are you using? Solid or dotted?
Solid.
Solid. Why is it solid this time? Because there's a solid line in my symbol, right? I can be greater than or equal to, so I am going to connect using a solid line. Okay. And which way are we going to shade?
On top.
Why are we going to shade on top? Because if it's greater than, we are going to shade above our line. Yes. So it's going to be all of this. All of this. All right, here we go. I'm about to ask you what's a solution or not. You ready for me? All right, so Josh. Yes, no, you got it. Is the point 7,1 a solution?
No.
Why not?
Because it's not.
Good. 7,1 is about right here. That is not in the shaded region, therefore it is not a solution. Good. Angelica, you give me a point that is a solution. -2, 4. We go right here. Do y'all agree with her?
Yes.
Absolutely. That's in the shaded region. Good. All right, Dylan. I was looking at Dylan, and then you said call on me. Tyler Dennings. Which one?
In or out? A solution.
Give me one that is not a solution.
All right. +6, -9.
Yes, not a solution. Give me one that is a solution. Tyler, give me one that is.
It is? -9, +6.
-9, +6. There we go. Beautiful. Good. What if I asked about the point, how about our y-intercept? How about 0, -2? Is this a solution?
Yes.
How come this time it is? It's on the line and the line is solid. There we go. Good. Still feel okay? All right. Yeah, how about the origin? 0, 0. Yes. Good. All right. Next. Okay. I have 2x plus 4y is less than or equal to 12. Do I need to change the way this is written?
Yes.
No. You don't. This is standard form.
Oh, that's right.
I have my x and y on the same side.
Oh, yeah.
So I can find my two intercepts. Okay? If I want x by itself, I'm going to say 2x. We're going to say equals 12. We're going to ignore this sign when we're solving for our intercepts. Okay? So my x-intercept is going to be where? Yes, our x-intercept is going to be 6. Good. And then my y-intercept, so I take my y piece out. 4y equals 12. Divide both sides by 4. Yep, we get y equals 3. There we go. So you didn't have to move anything around. Okay, solve for your x-intercept, solve for your y-intercept. All right, Kyle, am I going to have a solid or dotted line this time? I'm going to have a dotted line. Do y'all agree with Kyle? You should. Good. Why is it dotted? Because it is not equal to. Good. There's not a line underneath it. Get my dotted line. There we go.
And you're going to shade below because it's not equal.
Well, that's not, I'm not going to shade below because it's not equal to. I'm shading below because it is less than. The less than, my y's have to be less than here. So see how these y's are getting smaller? That's why we're going to shade down here. Because it says less than. All of my y values have to be less than this line. Okay. Then it would have been a solid line, but it wouldn't have changed where I shaded. It would still be below. Yep. Yep. Good question. Yes, sir.
But Dotted be going down.
Dotted does not tell you up or down. Okay? The less than or greater than tells you up or down. Equal to or not equal to tells you dotted or solid. All right, Emily. How about the origin? Is that included or not included in this set? I'm asking Emily. Is the origin going to be a solution? The origin is here, right? So is that a solution for this inequality? If it's in the shaded region. Yes, there you go. Yes, it is going to be a solution. Good. Jamie, how about 6, 0? Is it included?
It's on the line, would that be included?
It's on the line, but what is the line? It's not. Good, because my line is dotted, so our 6, 0 is not going to be included. Micah, give me something that is included.
I gotta say -1
Negative 1, positive 1? Good. Ellie, give me something that isn't.
8,
8, 0. Yeah, that is not included. Good. Very good. Feeling okay? Okay. Any questions for me right now?
No.
All right, let's go down to 6. All right, I see an x and y on the same side, so I want to try to do standard form. If I solve for x, am I going to get a whole number? We are not going to get a whole number. Yes, so because standard form didn't work for me, I am going to make this y equals mx plus b. Okay, so I need to get y by itself. What's the first step to make that happen? Subtract 3x from both sides. Yep.
Oh, then y's gonna be solid.
Well, we're not there yet. Jumping ahead of me. So 5y is greater than or equal negative 3x minus 10. And now what? Divide everything by 5. So we end up with y is greater than or equal to negative 3 over 5x. And then what is negative 10 divided by 5? Negative 2. So where am I going to start my graph? Where this negative 2? Yes, good. Start with my y. And how am I going to move to the next point? I am going to go down 3 and over 5 right here. Okay. And yeah, someone said a solid line. How do you know it's a solid line? Because it is equal to. And are we going to shade above and below? We are going to shade above because it says greater than. So we're going to have a solid line and we are going to shade above. Oh, shoot. Something just happened. Kayla, give me a point that is a solution to this set. A solution. What is a solution?
2 and 2.
2 and 2. Do y'all agree with Kayla? Yes, you should. You should agree with Kayla. All right. Stephanie, what is not a solution? Negative 4, negative 4. Good. Ooh. Dylan, is the origin a solution to this inequality? Yes, it is. Good. It's in the shaded region. Maddox, is the y-intercept a solution to this inequality? Yes, because it is a, anybody? It is a solid line. Good, Josh. Good. Still feel okay? Yeah? You feel good, and then you look at 7, you're like, well, I was feeling good. You'll be okay. Okay, so x is less than 7. So I know x has to be equal to 7. X has to be equal to 7, right? It has to be equal to 7. So let's get that. All right, so x has to be 7, and x has to always be 7. So is this going to be a solid or dotted line, number 1? It will be dotted. Good. So I know it is going to be dotted. Okay. So we know it has to be vertical or horizontal, right? Because there's no slope. But if all the x's have to be 7, then it's going to be, yes, Tyler, it's going to be a vertical line. It is undefined. Good. Yes. So whenever you have x is equal to, less than, greater than, to any number at all, okay, that will always give us a vertical line. Always, always, always. Okay. Okay, well, all your other values, all your other x's, they need to be greater than or less than 7. All of your x values need to be less than 7. So which way are you going to go? To the left. Good, because if you went to the right, they would all be bigger, right? I don't want to go over here. So yes, all of this. Is the origin a solution? Yes. How about the point 9, 2? No. How about 7 anything? 7, 1, 7, 10, 7, negative 6. None of those are going to work because our line is dotted. Good. What about 6.999992? Yes, it's not 7, right? So as long as I'm less than 7 with my x, we're good to go. All right. So we feel good about graphing, shading, knowing what is and is not a solution. Okay. So let's put this with an application of a word problem. Don't you freak, don't. You be okay. I promise. You are. You're going to be fine. You're going to be fine. Here we go. And you can laugh because we definitely dated this problem. All right. On school nights, you were allowed a maximum of 40 minutes total to play on computer games or to chat with your friends on Facebook. I know. That's why I said I dated myself with this question. What are the different amounts? What are the different amounts of time you can spend gaming or chatting? Okay. Well, before I start graphing things, I need an x and a y, right? So what is our x going to represent in this problem? Minutes on what? What's mentioned first? The games, right? And my y is going to be my minutes on Fabo. Okay. So yes, so here we go. So we have computer games or we have Facebook. How much time do I get to use on these two things? I have a maximum of 40 minutes. So can I go, I have to stay under the 40 minutes, right? I'm not allowed to go over. Okay, so I have to stay under 40 minutes. Can I be equal to 40 minutes? Yeah, I can spend 40 minutes, right? A maximum of 40 minutes. Okay, so how do I represent all the minutes together? Minutes on games and minutes on Facebook using the x's and the y's. Yes, good. Brandon got it. X plus y. So all of my minutes on games plus all of my minutes on Facebook have to be less than or equal to 40. Yes, you could use standard form, right? X equals 40, y equals 40. But what's the only issue with that?
There's no 40 on the graph.
There's no 40 on the graph I gave you. Oh my gosh, I'm the worst. So what can I do instead?
You can pick another number that.
Or I can make this slope intercept. Or change this to slope intercept.
Oh,
X
equals
less than or greater than y.
Yeah, let's subtract the x. This is what I need to do. So we have y is less than or equal to negative x. Yep. Plus 40. So how am I going to graph this? 40 is my y. Yep. Now, am I going to go, what's my slope, first off? It's negative 1. Am I going to go down 1 square and over 1 square? Tell me no.
No.
Look at the scale, guys. To go down a block is going down 5 minutes. To go over 1 block is to only go over 1 minute. So that's not my slope. Yeah. If I go down a block, which is 5 minutes, I have to also go over 5 minutes. 1, 2, 3, 4, 5. Gotta be careful with our word problems. You have to look at our scaling. You can't just go down 1 over 1. You cannot go down 1 over 1 because our scale does not match. Going down 1 is going down 5 minutes. So I have to go over 5 minutes. 1, 2, 3, 4, 5. Okay. So watch your scales. When I continue this line, is it going to be solid or dotted? How do you know? Because it says it is equal to. Yep. There we go. And are we going to shade above or below? How do you know that? Because it says less than. Good. So it's everything below the line. All right. This graph, though, it is not complete. My teacher's going to take points off. Oh, there you go. Need my labels. Mm-hmm. On the Fabo, yes. So this is minutes. Oops. There it goes. Minutes on games. And then this side is going to be minutes on Facebook. That's a little ugly. I'm sorry. Okay, so tell me a combination of minutes I can spend in my evening after school.
You can do 5 minutes and 30.
Well, here, give me a point first. 5 what? 5:35? Okay. Yep, it is on the line. So that means if I'm doing 5:35, I'm doing 5 minutes on what? On games.
35 minutes on
And 35 minutes on Facebook. Yes. Could I do 11 minutes on games and 5 minutes on Facebook? Yeah. I'm not using up all my time, but it's still allowed, right? Could I do 12 minutes on games and 35 minutes on Facebook? Nope, that is not going to work. That is not in my solution set. Good. So yes, a point, as Kayla pointed out, a point on the line will work for us because it's a solid line, or we can pick anything in the shaded region. Okay. How do we feel?
Good.
Feel good? We only have one more. We can do this. Only one more. Okay. Here we go. Numero 9. Numero 9. Ah, sorry. Okay. Read the question, please. I did earlier today.
I looked at it, but I didn't write it down.
You and 4 friends are going to see the new Twilight movie at the movies. Between the 5 of you, your parents give you, hey look, they gave me how much money? They give me $50 to spend on snacks. Okay. If popcorn costs $10, that's important. Popcorn is going to cost me $10 and drinks cost $5. What are the different amounts of drinks and popcorn you and your friends can get? Okay, so first things first, what are my variables? What is x going to represent for this equation? All right, x is going to be how much popcorn you have. Okay, and what is y going to represent? How many drinks I get. There you go. And I can't spend more than how much money? $50. So the money I spend has to be greater than or less than 50. Everything has to be less than. Could I spend all my money?
No. Yes.
Sure, I could. So it has to be less than or equal to the $50. I can't just do x plus y because I need to know how much each item is. There you go. So 10x plus 5y. Yes. So $10 for each popcorn plus $5 for each drink. That has to be less than the $50. Good. Okay, how am I going to graph this? Yes, good. I can use standard form. Absolutely. So if I cover up the y, and solve for x, we're going to have 10x, yep, is equal to 50. So I have an x-intercept at 5. And then if I cover up my x piece, I have 5y equals 50. So y equals 10. Yes, sir.
When do you know when to do that?
When you solve, well, your first clue is that the x and y are on the same side. And then you're equal to a number by itself. Then if you cover up each one, as long as you get whole numbers, you can keep going. But if you ever solve for x or y and you get a decimal or a fraction, that's when you should do the y equals mx plus b. Okay. Am I going to connect this using a solid or dotted line? Solid. How do you know? Because it is equal. I'm allowed to be equal to 50. I can spend it all. Okay. Now, where am I going to shade? Below. So am I going to shade everything below this line? No, I am not. Why can't I go all the way? Good. I cannot have negative popcorn and negative drinks. Okay? So my x and y have to be positive, meaning they have to be bigger than 0. Okay? So when I shade, I cannot go in the negatives. I cannot do it. Yeah, it is only, yep, it's only going to be this triangle. Yeah, it can only be the positives. Ooh, sorry, that was not pretty. There we go. It can only be inside this triangle because I cannot have negative popcorn or negative drinks. So tell me, how many popcorn and drinks could I buy for me and my friends? 2 what? I could get 2 drinks and...
4.
Well, 2 drinks is here.
Oh, wait, no. Wait.
I could get 2 drinks and 2 popcorns, right? This is my drinks, right? Down here is my popcorn. I could get 2 popcorns and 5 drinks. Yep, that's allowed. What if I wanted to spend all my money? I could do 1 popcorn and 8 drinks. What else? I could do no popcorn and 10 drinks if we're real thirsty. What are you saying? Yeah, you could do, no popcorn and 9 drinks. What else, Elian? Well, 7-1 is not, 7 drinks. Hold on. You're right. I went the wrong spot. 7 drinks, 1 popcorn. Yep, that's going to work. I wouldn't spend all my money, though. So, could I buy nothing?
Yeah.
Yeah, I could choose to buy nothing. Right? That's spending less than $50. Yeah, good. Okay, guys. So we got a couple minutes. Go ahead and start on your homework. Good job today.